Hello friends, welcome to the channel. So here you can see I have executed Tensorflow on port number 8888. So here it's showing that you can copy this URL to access the Jupyter notebook. In the previous video I have shown how to install Docker and pull the Tensorflow image. Copy this and paste it. Okay, also modify this to look like proper URL. So you can see the default files IPYNB. So what I will do here, I will create a new folder to start with linear regression project. Linear regression, and I have a project for cricket score. So I have downloaded those code in downloads folder. Load. In this file we have data from ESPN Crick Info, that is over and runs, for over how many runs they are making. So this will be used to plot the graph for linear regression. So linear regression, you can see this graph and in y-axis you can say runs and x-axis overs. So these are the plots. So y equal to mx plus c is the formula for straight line, and then this is just an example. This is not an exact example for overs versus run. So in linear regression artificial intelligence algorithm, that is a supervised learning. So in that we come to the conclusion and we plot the graph and we plot the line and we calculate the minimum error. So this point you can see this is very far from this line, so there is the deviation is too much here, and these are the plots. So the maximum dots are near this line, so we have to find that line which is very near to all the dots. So this is the formula for plotting x, y. So we can say x is overs and y is runs, and these are the formula for getting the m. So y equal to mx plus c is the formula for line. So to calculate m we are using this formula, and to calculate c we are using this formula. So finally we get the y equal to mx plus c, and then in that we put x equal to 1, 2, 3, 4, and then we get the corresponding y value. So here we can see. So similarly here we have the data, and the second is so in this notebook we can create our new file here. So here is our script Python. So we have imported pandas and numpy and all this, and so from ESPN Click Info, this link we are this is the URL, and then it is getting that HTML page and pass HTML using beautiful soap. So this is API Python. In the 442, India won the match actually. So data in JSON format, copied and created a JSON file .json that I have shown already, loading data from JSON to data frame and dropping wickets column. So this file is being opened and the data is loaded in that. So Python is providing all these APIs by default, so our work will become very easy. So here we can say C over 1 run is 6, and per over we can see the run rate. So total runs also is plotted here. So we are just predicting at the end of 10th over, 20th over, 30th over, so how many overs is still required to win the match. So after end of each over or phase, we are just predicting that. We are plotting runs against over. This is over and this is runs per over. So addition, if you add all this, we'll get the highest run made in this over and this over, that is around 20 runs. So matplotlib is used here to this is not a perfect straight line, but if we draw a line here, so we get all the dots which are near to that line, so deviation is less. Loading training data until 10th over. So model.predict is used to predict the score or winning over. And why printing prediction to find the over where the score is crossing the target 322. So we can see here around 43rd over we crossed the target. Preparing test data from 21st over to 50th over. So if we start predicting in the 20th over itself, so 20th over is going on and we have started our prediction here. Model predict. So here we can see the little deviation. So at the end of 20th over, we are predicting the win. So at the end of 20th over, so here it is saying 45th or 46th over, but actual win is there in 42nd over. Until so now we have seen 20th over. Here again start with 30th over. Here you can see after 30th over we have started the prediction. So here also little deviation is there. So deviations will be always there, as we see in cricket matches. Our predictions sometimes go wrong, but it's almost similar. It's almost closer always. As we see that in 20th over, if a team has scored 150, we predict the total score as 350 or 380. So it's almost 90% of time it becomes true. So that's it. Summary was to explain the linear regression and the plotting y versus x, and finding the m and c. There is no more complexity in this algorithm, and then predicting the over by predicting the runs by putting the value. First you find the m and then the constant c, and then put value y equal to 1, y equal to 2, y equal to 3, and then so the summary is here. So here we have again started with 30th over, and in 30th over we are still predicting in which over. For example, the target is 350, and in 30th over we have made 300. So we can say in another 5 or 6 over we'll win. So that is our prediction. But if batsmen will start playing slow, so their little deviation will come. So in terms of talking about data, we don't know how the actual and natural behavior will be. Maybe a bowler will be able to pick hat-trick, and then the match will slow down. So here we are just predicting with the data. In 30th over, if we have crossed 300, so we are going with run rate 10, and in next 5 over we'll make 50. So almost in that match, India was consistent. So run rate of 7, so run rate of around 6.87 they maintained, and then they were able. So the deviation is very less. So the summary is y equal to mx plus c is the straight line formula, and we find the m and c as I have shown you in that there is a formula to get both, and then we put the value of x equal to 1, x equal to 2. So here y axis is runs and x axis is overs. So we can uh, put the value in y equal to mx plus c formula, and we get the number of overs. So that's it, and I have put the link of the code in this video also, and in previous video also you can see I have put the drive link where this code is there, and I have also illustrated how to pull the image of TensorFlow and get to start with this artificial intelligence codes, and on each algorithm we'll be posting videos so that you directly connect with the real-time scenarios. So thank you friends, thanks for watching. Like and subscribe the video, and also post your use cases, and also put your comments so that we make better videos. Thanks.